Hi, my name is Justin Cirillo, and we are back for another Seminole Space Science episode where we are going to be exploring the universe and all of the cool things that are going on inside of it. In a previous episode, we learned all about nebula formation, and we did a really cool activity creating nebula spin art. If you haven't had a chance to watch that episode, click on the link in the description below. In this episode, we are going to be talking about star formation.
Star formation?
Whoa, hi.
Hey, how's it going?
Who are you?
I am Dr. Demetrius Deuteron, head extraordinaire of science. And you are?
Well, welcome. My name is Justin.
Justin,
I'm
nice to
here
meet you.
Yeah,
Nice to meet you. Yeah. So, you got some really cool stuff set up here. What are you doing?
Well, since you're an expert on star formation, that's exactly what I'm trying to show everyone about today. So, I've got some really cool tools here that we are going to use to help teach kids about how stars form. We have here a nebula. A nebula similar to the Orion Nebula. Okay?
Okay, that sounds pretty cool.
Interstellar gas
And what are
and
these,
dust combined.
What do these balls represent?
Well, today these are going to represent helium and hydrogen. Two of the most abundant elements in the universe. Those two elements happen to be the main elements inside gas giants like Jupiter and Saturn, stars like our sun,
Right.
a low mass star, and then high mass stars.
All right. And so what's going on with, am I going to use this to blow dry my hair or something? Because I could.
Yeah, give it a shot.
Oh, okay. Let's see here.
Actually, never mind. Your hair's perfect.
Okay.
Your hair's perfect.
Hey, well,
All
you
right.
know, I mean, you mentioned it. So, all right. So, Jeremy, what are we doing here?
No, it's Jason. No, Justin.
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 Okay.
Yeah.
Okay.
All right. So this is going to represent gravity. In order to form a star inside the nebula, gravity pulls all of these elements together. I'm going to have you recreate gravity to pull together these elements and try and create first a planet.
All right. So we got this thing down here. So it looks like we got this apparatus here. We got. If we fill enough balls to this line here, we can create a gas giant like Jupiter or Saturn or some of those large hot Jupiters and other places we call exoplanetary systems.
You got it.
And of course, if we add more of those balls, eventually we have enough hydrogen and helium to compress to form a low mass star like our sun. And then of course, if we keep going, we get bigger and bigger and bigger stars. Let's do this. All right, Jason, let's take a look at this. All right.
Here we go.
Okay, all right, here we are.
It's Justin.
Justin.
Yes,
okay.
yes.
All right. So what we're gonna do is we're gonna go ahead and begin this procedure. So I need to put this on high, right?
Oh, I
We
would.
need a lot of gravity.
A lot of gravity.
A lot of gravity. Here we go. All right. Okay. So all right.
You're doing it, doctor. A little bit more. We need a little more time. We need a little bit more gravity. We're getting close.
All right. So let's see. We had enough time for gravity to compress these hydrogen and helium together. Let's see what we created with this procedure. So, Jeremy, you want to go ahead and take that off there?
Here we go. Oh no, it's Justin.
Justin.
It's Justin.
Why can't I get that name right?
It's all right,
It's an
it's all
easy
right.
name to remember.
As long as we get this right.
Okay, all right.
Here we go.
Let's
here
take
we
a
go.
look here.
Do we have
Okay,
enough
all right.
for a gas?
I think we do.
Wow.
Yeah, so this would probably be a little bit bigger than Jupiter.
Yes.
A
Yeah.
little bit bigger than any of the gas planets that we have in our solar system. But maybe there are exoplanetary systems now, Jupiters, that are 4 times or 10 times the size of Jupiter. But aren't there certain stars, we call them brown dwarfs, that aren't quite stars, but aren't quite low mass stars, right? They just don't have enough gravity to compress into a low mass star. So it looks like we're gonna need more of that stuff to make a low mass star, right?
Yes, sir.
Okay,
Let's do that.
all right.
So, more time, more gravity,
Oh, you missed one.
more
Oh.
mass.
We got a runaway hydrogen. There we go. Put
They're
it back
like
in there.
triples over here. I know. Here
All
we
right,
go.
let's see what we got here.
Let's create a star.
Okay.
Gravity-
All right. I'm gonna
gravity
do the
ready?
hair dryer again. Here we go.
Here we go.
Make sure it's on high. Here we go. Here we go. All right, we're adding more.
Just
All
like in
right.
the Orion Nebula, where you can see new stars forming with a telescope.
Look at that. We got a lot more hydrogen and helium this time. Let's see what we created this time. All right, let's see here.
Look at that.
Look at that. We're pretty close.
That looks pretty
All
good
right,
to
pretty
me.
close. So we pretty much produce a slow mass star. These are red dwarfs. These are smaller stars than our sun, and of course, our sun is considered low mass, right?
Absolutely. Absolutely. Our star, a low mass star. You know, one of the most common things kids ask us is our star going to go supernova? Is our star going to explode? Is our star going to create a black hole? Low mass stars cannot do that. They don't have the size and the mass to create those types of things. You need a high mass star for that environment. So there's high mass stars out there, right?
That's right. That is correct, Jeremy. We're going to go ahead and put this stuff back in here. And let's see what we got this time. Yeah,
absolutely.
Yeah.
Oh, and Doctor, it's Justin.
Justin.
Yes,
I don't know. I'm gonna figure this out one of these days.
They're gonna name a star after me after this episode.
That's true. That's true. Okay. All right. So we need to get a lot of hydrogen and helium in here. So this time, actually, you know what? You got the power. Let's see if you can try it this time.
All right.
Let's see if this guy, he looks like he's fit for it. Look at that.
Come on, high mass.
Oh my goodness, this man's wild.
Wow.
All right.
That's a lot of gravity.
Okay.
That's a lot of mass.
All right.
Put it in, Doc.
Okay,
and
let's see what we got. Are you ready? Let's do it. All right, here we go. Oh, yeah, you did it. All right.
Excellent.
All right, so as you can see here, we've created a high mass star. Now, are there any high mass stars out there that our viewers can see in the sky?
Well, at the winter months that are coming up right now, one of the most famous constellations in the night sky is the Orion constellation. Rigel is one of the rock stars, one of the high mass stars in that constellation.
Right.
Where is that, if they wanted
It's
to
in
pick
Orion the Hunter. So it's a beautiful constellation. You can see 3 stars for its belt. You can see it's really high up in the sky, especially in the northern hemisphere during the winter or in the summer for the southern hemisphere. And it is a fantastic place to look at. Now, of course, eventually, these high mass stars, they don't last a very long time. They only last for a few million years. But eventually, what's happening in both low mass and high mass stars is they're compressing hydrogen that's in there into helium. So, believe it or not, I got this little device over here that has compressed helium. And you'll see here,
there is helium in stars. And that's where helium comes from. It comes from stars. Isn't that amazing?
You okay, Dr. D?
I think I'm all right, Jeremy.
Okay, well, I'm glad that the helium is safe for you to do that. Oh, and it's Justin.
Justin,
Yes,
right?
yeah.
Justin. Okay, all right. Well, okay, looks like my voice is finally returning there. Now, how can somebody make one of these at home?
Yes, and that's the coolest part about this video series is we're taking everyday objects and putting them in a scenario where you can create these types of learning experiences at home. You've got a basic basket, you've got some acrylic, you've got even these foam balls that you can get at any type of craft store. So go pick up some of these items. You might even have a lot of these around the house, and you can recreate gas giant planets, low mass stars, and high mass stars, and get a better idea of how a nebula can form.
And you can even make a game out of this. Whoever gets a high mass star wins or something, right? Well, Jeremy, it was a wonderful time to spend with you today. I hope you enjoyed my time. I enjoyed my time with you, and I've learned a lot about star formation too that I didn't even know too. So there you go, man. Take care.
Thank you,
and,
Dr. D.
We'll see you next time. All right.
All right.
Bye, everybody.
All right. Tomorrow I'm having my name changed. Careful, D. Careful. Bye-bye, everyone.